United States customary units are a system of measurements commonly used in the United States. The U.S. customary system developed from English units which were in use in the British Empire before American independence. However, the British system of measures was overhauled in 1824 to create the imperial system, changing the definitions of some units. Therefore, while many U.S. units are essentially similar to their imperial counterparts, there are significant differences between the systems. The majority of U.S. customary units were redefined in terms of the meter and the kilogram with the Mendenhall Order of 1893 in practice, for many years before. These definitions were refined by the International Yard and Pound Agreement of 1959. Americans primarily use customary units in commercial activities, as well as for personal and social use. In science, medicine, many sectors of industry and some of government, metric units are used. The International System of Units, the modern form of the metric system, is preferred for many uses by the U.S. National Institute of Standards and Technology. History. The United States system of units is similar to the British imperial system. Both systems are derived from English units, a system which had evolved over the millennia before American independence, and which had its roots in Roman and Anglo-Saxon units. The customary system was championed by the U.S.-based International Institute for Preserving and Perfecting Weights and Measures in the late 19th century. Advocates of the customary system saw the French revolutionary, or metric, system as atheistic. An auxiliary of the Institute in Ohio published a poem with wording such as, "down with every metric scheme," and "a perfect inch, a perfect pint." One adherent of the customary system called it a just weight and a just measure, which alone are acceptable to the Lord. The U.S. government passed Omnibus Trade and Competitiveness Act of 1988, which made the metric system the preferred system of weights and measures for U.S. trade and commerce. The legislation states that the federal government has a responsibility to assist industry as it voluntarily converts to the metric system, i.e., metrification. This is most evident in U.S. labeling requirements on food products, where SI units are almost always presented alongside customary units. According to the CIA Fact Book, the United States is one of 3 nations that have not adopted the metric system as their official system of weights and measures. U.S. customary units are widely used on consumer products and in industrial manufacturing. Metric units are standard in science, medicine, as well as many sectors of industry and government, including the military. There are anecdotal objections to the use of metric units in carpentry and the building trades, on the basis that it is easier to remember an integer number of inches plus a fraction than a measurement in millimeters, or that foot-inch measurements are more suitable when distances are frequently divided into halves, thirds and quarters, often in parallel. The metric system also lacks a parallel to the foot. Other nations had, or still have unofficially, customary units of their own, sometimes very similar in name and measure to U.S. customary units, since they often share the same Germanic or Roman origins. Frequently, however, these units designate quite different sizes. For example, the mile ranged by country from 1/2 to 5 U.S. miles. Foot and pound also had varying definitions. Historically, a wide range of non-SI units were used in the U.S. and in Britain, but many have fallen into disuse. This article deals only with the units commonly used or officially defined in the U.S. Units of length. For measuring length, the U.S. customary system uses the inch, foot, yard, and mile, which are the only 4 customary length measurements in everyday use. Since July 1, 1959, these have been defined on the basis of 1 yard equals 0.9144 meters, except for some applications in surveying. The US, the United Kingdom and other Commonwealth countries agreed on this definition, and so it is often termed international measure. When international measure was introduced in the English-speaking countries, the basic geodetic datum in North America was the North American datum of 1927, which had been constructed by triangulation based on the definition of the foot in the Mendenhall Order of 1893, that is 1 foot equals 1,203,937 meters. This definition was retained for data derived from 27 Namibian dollars, but renamed the U.S. survey foot to distinguish it from the international foot. For most applications, the difference between the two definitions is insignificant. One international foot is exactly 0.999998 of a U.S. survey foot, for a difference of about 1/8 inch per mile, but it affects the definition of the state plane coordinate systems, which can stretch over hundreds of miles. The 27 Namibian dollars was replaced in the 1980s by the North American datum of 1983, which is defined in meters. The SPCSs were also updated, but the National Geodetic Survey left the decision of which definition of the foot to use to the individual states. All SPCSs are defined in meters, but 7 states also have SPCSs defined in the U.S. survey feet and an 8th state in international feet. The other 42 states use only meter-based SPCSs. State legislation is also important for determining the conversion factor to be used for everyday land surveying and real estate transactions, although the difference is of no practical significance given the precision of normal surveying measurements over short distances. 24 states have legislated that surveying measures should be based on the U.S. survey foot. 8 have legislated that they be made on the basis of the international foot, and 18 have not specified the conversion factor from metric units. Units of area. The most widely used area unit with a name unrelated to any length unit is the acre. The National Institute of Standards and Technology contends that customary area units are defined in terms of the square survey foot, not the square international foot. Conversion factors are based on Aston and National Institute of Standards and Technology. Units of capacity and volume. The cubic inch, cubic foot and cubic yard are commonly used for measuring volume. In addition, there is one group of units for measuring volumes of liquids, and one for measuring volumes of dry material. Other than the cubic inch, cubic foot and cubic yard, these units are differently sized from the units in the imperial system, although the names of the units are similar. Also, while the U.S. has separate systems for measuring the volumes of liquids and dry material, the imperial system has one set of units for both. Fluid volume. 1 U.S. fluid ounce is 1/16 of the U.S. pint, 1/32 of the U.S. quart, and 1/128 of a U.S. gallon. The teaspoon, tablespoon, and cup are defined in terms of the fluid ounce as 1/6, 1/2, and 8 fluid ounces. The fluid ounce derives its name originally from being the volume of 1 ounce avoirdupois of water, but in the U.S. it is defined as 1/128 of a U.S. gallon. Consequently, a fluid ounce of water weighs about 1.041 ounces avoirdupois. The saying, "a pint's a pound the world around," refers to 16 U.S. fluid ounces of water weighing approximately 1 pound avoirdupois. An imperial pint of water weighs 1.25 pounds. There are varying standards for barrel for some specific commodities, including 31 gallons for beer, 40 gallons for whiskey or kerosene, and 42 gallons for petroleum. The general standard for liquids is 31.5 gallons or half a hogshead. The common 55-gallon size of drum for storing and transporting various products and wastes is sometimes confused with a barrel, though it is not a standard measure. In the U.S., single servings of beverages are usually measured in fluid ounces. Milk is usually sold in half pints, quarts, half gallons, and gallons. Water volume for sinks, bathtubs, ponds, swimming pools, etc. is usually stated in gallons or cubic feet. Quantities of gases are usually given in cubic feet. Minims, drams and gill are rarely used currently. The gill is often referred to as a half cup. Dry volume small fruits and vegetables are often sold in dry pints and dry quarts. The U.S. dry gallon is less commonly used, and was not included in the handbook that many states recognize as the authority on measurement law. However, pecks, or bushels are sometimes used, particularly for grapes, apples and similar fruits in agricultural regions. Units of mass. There have historically been 5 different English systems of mass: tower, apothecaries, troy, avoirdupois, and metric. Of these, the avoirdupois weight is the most common system used in the U.S., although troy weight is still used to weigh precious metals. Apothecaries weight, once used by pharmacies, has been largely replaced by metric measurements. Tower weight fell out of use in England centuries ago, and was never used in the U.S. The imperial system, which is still used for some measures in the United Kingdom and other Commonwealth countries, is based on avoirdupois, with variations from U.S. customary units larger than a pound. The pound avoirdupois, which forms the basis of the U.S. customary system of mass, is defined as exactly 453.59237 grams by agreement between the U.S., the United Kingdom, and other English-speaking countries in 1959. Other units of mass are defined in terms of it. The Avoirdupois pound is legally defined as a measure of mass, but the name pound is also applied to measures of force. For instance, in many contexts, the pound avoirdupois is used as a unit of mass, but in some contexts, the term pound is used to refer to pound force. The slug is another unit of mass derived from pound force. Troy weight, avoirdupois weight, and apothecaries weight are all built from the same basic unit, the grain, which is the same in all 3 systems. However, while each system has some overlap in the names of their units of measure, the relationship between the grain and these other units within each system varies. For example, in apothecary and troy weight, the pound and ounce are the same, but are different from the pound and ounce in avoirdupois in terms of their relationships to grains and to each other. The systems also have different units between the grain and ounce. The dram in avoirdupois weighs just under half of the dram in apothecaries. The fluid dram unit of volume is based on the weight of 1 dram of water in the apothecaries system. To alleviate confusion, it is typical when publishing non-avoirdupois weights to mention the name of the system along with the unit. Precious metals, for example, are often weighed in troy ounces, because just ounce would be more likely to be assumed to mean an ounce avoirdupois. For the pound and smaller units, the U.S. customary system and the British imperial system are identical. However, they differ when dealing with units larger than the pound. The definition of the pound avoirdupois in the imperial system is identical to that in the U.S. customary system. In the U.S., only the ounce, pound in short ton, known in the country simply as the ton, are commonly used, though the hundredweight is still used in agriculture and shipping. The grain is used to describe the mass of propellant and projectiles in small arms ammunition. It was also used to measure medicine and other very small masses. Grain measures in agricultural practice. A bushel is a fixed volume of 2,150.42 cubic inches. The mass of grain will therefore vary according to density. Some nominal weight examples are: 1 bushel equals 56 pounds equals 25.4012 kilogram. 1 bushel equals 60 pounds equals 27.2155 kilogram. 1 bushel equals 48 pounds equals 21.7724 kilogram. In trade terms, a bushel is a term used to refer to these nominal weights, although even this varies. With oats, Canada uses 34 pounds bushels and the USA uses 32 pounds bushels. Cooking measures. The most common practical cooking measures for both liquid and dry ingredients in the U.S. are the teaspoon, tablespoon, and cup, along with halves, thirds, quarters, and eighths of these. Pounds, ounces, fluid ounces, and common sizes are also used, such as can, jar, square, stick, or fruit, vegetable. Units of temperature. Degrees Fahrenheit are used in the U.S. to measure temperatures in most non-scientific contexts. The Rankine scale of absolute temperature also saw some use in thermodynamics. Scientists worldwide use the Kelvin and degree Celsius. Several technical standards are expressed in Fahrenheit temperatures, and American medical practitioners often use degrees Fahrenheit for body temperature. The relationship between the different temperature scales is linear, but the scales have different 0 points, so conversion is not simply multiplication by a factor. Pure water is defined to freeze at 32 degrees Fahrenheit equals 0 degrees Celsius and boil at 212 degrees Fahrenheit equals 100 degrees Celsius at 1 atmosphere. The conversion formula is easily shown to be, or inversely as other units. 1 board foot equals 1 foot times 1 foot times 1 in equals 2.360 cubic decimeters. 1 British thermal unit 1055 J. 1 ton of refrigeration equals 3.517 kilowatts. 1 calorie equals 4.184 J. 1 food calorie equals 4.184 kilojoules. 1 foot-pound 1.356 J. 1 hand equals 10.16 centimeters. 1 horsepower 745.7 W. 1 R value 0.1761 RSI. 1 slug equals 1 lbfs 2 feet. 1 U equals 1.75 in. Various combination units are in common use, including the foot-pound and the pound per square inch. These are straightforwardly defined based on the above basic units. Sizing systems are used for various items in commerce, several of which are U.S.-specific. U.S. standard clothing size. American wire gauge. Scoop sizes, numbered by scoops per quart. Other names for U.S. customary units. The United States Code refers to these units as traditional systems of weights and measures. Other common ways of referring to the system in the U.S. are standard, customary, or erroneously imperial, or English. Another term is the foot-pound second system, as opposed to centimeter-gram second system. Tools and fasteners with sizes measured in inches are sometimes called SAE bolts or SAE wrenches to differentiate them from their metric counterparts. The Society of Automotive Engineers originally developed fasteners standards using U.S. units for the U.S. auto industry. The organization now uses metric units.